Okay, hello again, everyone. Again, my name is Ross Ignall. I'm the Director of Product Management at Dranetz. I'm joined here in the room today. You should be familiar with these gentlemen, with Thurman Bridgers and Ken DeMario. Both of them help out with our technical support and customer applications. Today's session, we're going to focus on a different approach to what we've done in the past. This is our third group of web meetings that we've had during 2020. We've kind of done more classroom and demonstration stuff, but this one and in about 3 weeks, we're going to have another one that focuses on applications of our product, not in a generic format, and it can do this, but we're going to show you what it does, and we're going to show you data and how to set it up for those particular applications, highlighting the benefits to you as a user for these products, how to configure the instrument properly for this application, but also review some data, some live field data that our customers have shared with us for that particular application. So it's a little new format for us today, so just bear with us with a little bit of, if we have some technical difficulties, but as usual, we're gonna do a lot of question and answer during this, but we will be using the chat capability within Zoom for the Q&A. It's just there's too many people to have a voice dialogue on a web meeting like this. So if you do have a question, please chat it up and provide that to us. We'll be monitoring the chats during the meeting. So just chat up any questions. If we don't get to your question immediately, please forgive us. We'll find an appropriate time to do that. So we are going to divide this into two modules. We have Dranetz HDPQ generator and UPS testing is our first module today, followed by a Dranexpert introductory module. We're going to review the features and capabilities of Dranexperts, but also do a demonstration on its web-enabled interface, how to configure the instrument, how to review data on the instrument, and we're going to actually show you Dranexpert data, real data taken in our DranView software. So we're going to review that. So again, our next training will be next Wednesday at this same time on November 18th, and this will be just a general HDPQ monitoring training. We had a lot of requests from our training in the spring where we did this a few times and people wanted to see it again. So we're happy to provide that to you again, but this time we have better facilities to record it. And just a reminder that today's presentation will also be recorded, and we'll be posting it on YouTube with also links back to our website. So, okay. Now, just again, we'll review a little bit about Dranetz for those of you who have not participated before. We are located in Edison, New Jersey. We are in our classroom in our facility right now. Edison is not very far from Manhattan. I'm circling where Manhattan is in, let's say, less COVID times when we were allowed to have visitors and visitors wanted to come visit us. A lot of folks would want to actually visit Dranetz, but under the guise to a trip to Manhattan and going and seeing New York City, especially in the coming months with the holidays coming up. People would love to go see it. So we are very well situated, and hopefully once COVID comes down, we're happy to have you at our facility, and we hope you're happy to visit us and we can all travel again. So very convenient location in the Northeast of the United States. What is our product and service portfolio? We manufacture three-phase power quality, demand and energy instruments. We're going to speak about two of them today, actually. Our HDPQ family and our Dranexpert family comes within that scope of supply. We also make permanently installed power quality, demand and energy instruments. So these are fixed products that get installed in substations and industrial environments. Of course, we make analysis software for our portable and permanent products. I'm referring to our DranView software that we're going to focus on later today, as well as our PQView and PQView DE software for our fixed systems. However, we are also the master distributor of the company who owns us and their products, called Gaussen Metrowatt and Gaussen Photo products. They offer a full line of precision multimeters and testers, electrical safety installation testers, installation testers, multimeters, and other types of testers. So, we are the master distributor. If you see green products, sold by Dranetz, they are provided by our German parent company. So, one thing that we're proud of is free technical support. This is a free service today that we're offering for our customers for training. And also Ken and Thurman and others, including myself, are available to help you with our products. We want you to not only buy them, of course, but be successful in their use, know how to use them properly. And as you saw by our web trainings back in the summer and in the spring, we want to give you as much information to be successful with them. And again, that's our desired outcome today. We offer remote and on-site training when we're allowed to do that again. These are paid for trainings. We're doing a lot of web-enabled sessions, Zoom sessions, team sessions, GoToMeetings, whatever the customers prefer. And we basically take our on-site training and we make it remote. And we're there to help our users install our instruments. Of course, we can't physically be there, but more importantly, how to configure them for their particular application, how to get data out of the instrument, how to load it into our software, whether it be DranView or PQView or PQView DE, and also how to get the best out of the analysis for that. So that is paid for training. It's built right around your needs, and usually it's a half a day, or even more for large systems. Usually that's a fixed installation application. So our website, this is how you registered and found out about this meeting today. We're very proud of Dranetz.com. It's gone through a major transformation over the last year or two. It is, of course, an online catalog for our products, but it's also a library of educational information just for the industry in general. And of course, application information about our products, such as these recordings of these web meetings, case studies, tech tips. You can see we're focusing on our tech tips and a lot of application information on our social media. We have a renewed push for that. So please check us out on Facebook and LinkedIn and the other platforms, and please follow us. You'll find news and other timely information coming out through those channels. So last but not least, we are proudly made in the USA. We've been in our present building for quite some time. So basically, products that are designed by Dranetz are manufactured in our facility here in Edison, New Jersey, where Thurman, Ken, and I are located right now. So we do sell other products from our sister companies that are made in Europe and other locations, but the products that we design are manufactured here. So you can see a collage of the products. We are going to speak this afternoon or this morning, depending upon your time, about our HDPQ. We're going to start with that again, with the applications of generator and UPS and mission critical testing. And then we're going to move over to our Dranexpert. This is a very new product for us that we just started shipping in October. So we're going to talk about its capabilities, but also focus on how to configure it, how to set it up properly, and how to review the data from it. But we do have other product lines. We have our fixed product line, our 61000, our HDPQ data node, and all of our products have accompanying software. So on our portable line, we have our DranView software, which I think a lot of you are very familiar with. And on our fixed systems, we have our PQView DE software, as well as our PQView software, which we covered in prior sessions. We covered this software, but Thurman's going to be doing a session in December on a tour of PQView and PQView DE. So if you're interested in learning more about that, feel free to go to the website and register for that session if you have not done so already. And last but not least, these are the products I was referring to from Gaussian Metrowatt and Gaussian Photo. These are a selection, just a sample of some of the products, multimeters. These are safety testers. This is a light meter from Gaussian Photo right here. So a full line of test and measurement instrumentation. And again, Dranetz is the US distributor, North American distributor for these products. So what we're here to talk about today, let's get to the subject at hand. Again, the HDPQ family, which includes the portable, which you see on the right. There are 4 models of portable: Visa, Guide, Explorer, and Explorer 400. And there are 4 models of the SP Visa, Guide, Explorer, and 400. The difference between these two instruments is mostly in packaging. If you buy a Visa SP and a Plus SP, they are the same product measurement-wise and specification-wise. The difference is in the packaging, where the portable line, the Plus line, it has a local user interface, yet you can still remotely control it, as Ken is going to show you later. However, the SP, of course, does not have a local user interface. It does not have an SP, but it has those same remote control capabilities as the Plus line does. So what you see remotely is identical on both of them. However, the SP has a capability not available on the Plus, and that's the power from the phase that you're measuring. So it has the ability to literally jump over your measurement inputs if they're below 600 volts. These are 1,000-volt instruments. So if it's below 600 volts, you can jump it right over to the power supply inputs here and power your SP instrument right from that measurement phase, or just have a separate line cord for the instrument. That's your choice. You can just plug it right into the wall, whether it be a US 120 volt or a European or international 230 volt 50 hertz. Okay, so that's your choice. So what we talk about today is common. When we talk about a Visa, we're referring to the SP and the Plus version. The Guide, the Explorer 400 is the same. Okay, so these instruments have a lot of capabilities, a lot of features. They have a lot of benefits, and we're going to break them out. And for this, we're going to talk about the benefit of generator UPS testing and just mission critical commissioning. They have a lot in common. So we're going to focus on that today. So what types of applications fall under this kind of umbrella of capabilities? And you have just basic mission critical commissioning and testing. And these are data centers, computer centers, phone centers like cellular sites, insurance companies with big data centers. So really these are sites that usually have some sort of UPS system, some sort of generator backup, and they need to basically look to see, I have a utility supply, maybe multiple supplies, but when that hiccups or it has an issue, that it has an orderly switch from UPS to generator and then back to utility when that main or primary supply is restored. So these products are ideally suited for measuring those and detecting those transitions, and for the purposes of commissioning these systems, for the purposes of testing them just to make sure that everything is going fine, and for troubleshooting when things don't go fine. These are very complex electromechanical devices that are prone to failure themselves. A lot of these things don't tell you when they're failing. So power monitoring systems and portables like this, and even our fixed products, help understand your system and improve the uptime. For this particular application, we're talking about transfer testing, maybe from utility to generator back to the utility, back and forth, things like that. System load step testing. So we're talking about commissioning, and this is the application that Ken's going to go through, and we're going to show you some real data recorded for this application and displayed in TranView. But this is during the commissioning, a typical example where you bring the system from 0 to 25% load, and then to 50% load, to 75 to 100, and then you step it back down. And then very typically they'll go in kind of the impulse loads. I'm sure the transient loads is maybe a better term for it. Well, they'll go from 0 to 25, then bring it down to 0, 0 to 50, 0 to 75, 0 to 100, and bring them back down. And we'll show that as well. So that's very, very typical. So along in this, we're doing UPS testing, make sure its output is regulated within the capabilities, make sure that there's no big disturbances on the output of the UPS. And same thing for generators, make sure the generators are firing up, they're holding the load during transfer testing. This is also used for load profiling, looking at the loads under UPS or at any point of your system, making sure that they are within your design specifications, and of course the generic general troubleshooting. So when something doesn't go wrong and the you-know-what may hit the fan, these products are ideally situated for this. So the HDPQ family, and specifically the Plus and the SP that we're going to discuss today, have a lot of capabilities, and a lot of you have seen that. We actually recommend to our customers kind of treat these products like Microsoft Excel, to use another analogy, where Excel's got a ton of capabilities. You're going to only use a fraction of it. So if a capability doesn't apply to your application, you just ignore it. You pretend it doesn't exist, and that's a very common utilization of our products. Not every capability is used in every application, but focusing on these generator and UPS testing applications, what are the main capabilities and benefits of the HDPQ family? They're wave-shaped triggers. They're the traditional RMS voltage, like it dips and swells, as well as transients for voltage. They're RMS current triggers, where you can actually have an RMS limit to detect a current trigger, as well as RMS transients. But a main capability is the recording depth of the instrument or instruments. So Basically, for commissioning, you want to do your step loading, do whatever's appropriate, but you want to be able to record a large recording depth. Do a transfer to UPS and hold it for a minute and see what's going on and measure the capabilities, have that constant measurement going on. And we can do that in some of the models. That's why we say model dependent. And I think it's on the next slide or 2 slides will help you choose that. Harmonic measurements, they will let you look at the harmonics on your mission critical bus or at any point of the system, as well as, of course, the power of DranView in the reporting and the analysis. So we'll look at the next slide. How do you choose the right model? So there's 4 models available. There's the Visa level, the Guide, the Explorer, and the Explorer 400. They go kind of bottom up for capabilities. And of course, you increase the cost a little bit as you go up. But there's a lot of differentiating capabilities between them as you go up the model chain. But those that are most important to this application really lies in the recording depth. And what I mean is that if you look at the Visa, our entry-level product, it has 100 cycle recording depth. And what that means in real time, that's about 1.67 seconds at 60 hertz and about 2 seconds at 50 hertz. One of the biggest differentiating features between the Visa and the Guide increases that recording depth. It also adds Wi-Fi and our answer modules and things like that. But specific to this application, the 100 cycles on a Visa goes up to 10,000 cycles on the Guide, and everything higher the Guide in our product line, meaning the Explorer and the Explorer 400. So, but it includes all the capabilities of the Visa. So we move from 100 cycles in about 1.67 seconds at 60 hertz up to 10,000 cycles and over 2 minutes recording time at 60 hertz and over 3 minutes recording time at 50 hertz. So that's where that frequency makes a big deal. Just for information, the Explorer has all the Guide capabilities, but it adds high-speed transient capabilities. The Explorer 400 has all the Explorer capabilities, but gives you the ability to measure 400 hertz measurements. Probably not applicable in this type of utilization, but that's for aviation and shipboard and stuff like that distribute power at 400 hertz. So which model do you choose? First of all 4 models, the Visa, the Guide, the Explorer, and the Explorer 400, they have the necessary triggers that we are discussing for this application. So if I go back a slide, they have the wave shape triggers, they have the RMS voltage and transient triggers, not high-speed transient triggers. That's only available in the Explorer, but that may not be necessary for a lot of these applications. Sometimes it is, and some people are interested in that, but that's not an overriding requirement by many of our customers. So the Visa also has the current triggers, but it doesn't have that large recording depth. That's something that it does not have. But it does have harmonics, and it does have, of course, that DranView capability. So when we talk about it, really it's an introspective look for your application. Does this recording depth meet your needs? Is 100 cycles enough? 1.6 seconds at 60 hertz or 2 seconds at 50 hertz? If that's more than adequate for your application, then the Visa may be appropriate for your application. That's up to you, okay? We can't answer that question for you. However, most customers are using the Guide because they do need more than this 1.6 or 2 seconds, depending upon where you live. They do need many seconds, sometimes minutes of recording to do the proper analysis and the testing for their commissioning. So we work very closely with virtually every UPS manufacturer, virtually every generator manufacturer, and a whole bunch of mission critical facilities, and that's what they're feeding back to us, that the Guide and the Explorer are what they're choosing for this application, and the minimum level is the Guide. But again, your choice can be the Visa. Just understand that this is a limitation for you. All right. So that's the biggest decision maker in this. Okay, just some miscellaneous considerations, and there's really only one listed here, and this is just a general thing that we recommend, is just make sure you choose the right CETs for your application, because you're going to take something from 0 load to 100% load. You want to make sure that you can look at some overshoot and have some high range. So As an example, if you have a 1,000 amp bus, maybe you don't want to have a 1,000 amp CT. You want to have some headroom on top of that. And conversely, you don't want to, undersize or oversize your CTs either. And you don't want to have this huge 3,000 amp CT for a 100 amp bus, if you can understand that. Just as a little tip, most of the customers in this application, and in fact in general, choose our flex CTs. And there's really two reasons why people choose the flex CTs. One of them, and the majority of the time, it's the wide measurement range. Even our most common CT, which is the 24-inch 3,000 amp flex, has that switch on it where you can switch the amperage or the current range from 30 to 300 to 3,000 amps. And again, as a tip, you want to make sure your measurements are right in the middle of that. And you're not going to clip the CT, but you're not going to be too low. All right. But also they choose these for the wide bandwidth. Okay. The clamp CTs typically have a bandwidth of 400 or 500 hertz. The flex CTs, about 10 kilohertz, depending upon which one you choose. It's 5, 10, even higher, depending upon which one you choose. Has more than enough to capture the harmonics and even transients for many of these applications. So, okay, let me just address a question that came in here real quick, because I think it may be relevant. From D-Sage, I apologize. I don't, if I mispronounced that, but I'm sure it's an abbreviation. And he or she writes, for UPS applications, is there dual input for UPS output and load consumption and the battery level? I'm not quite sure I understand the question. If you could just elaborate a little bit more. But for the sake of this test, we're typically looking at the UPS output in a mission critical sort of application. And so they're looking at stepped and load testing on that UPS output. So we're measuring one three-phase source. When we talk about fixed systems or larger portable tests, oftentimes we have an instrument on the input of the UPS and an instrument on the output of the UPS. Oftentimes to key in on the battery level, the benefit of any of our products, our fixed products or our portables, is we have differential inputs. We also have that spare D channel or neutral channel. A lot of times they wrap that around and measure the internal battery of a UPS. Again, in a HDPQ instrument for a portable application and for the fixed systems. We offer DC CTs that can measure the current on the battery, but also the voltage is just a direct connection for anything under 1,000 volts, AC or DC. So for the battery level, oftentimes they'll just wrap around one of the channels. So I apologize, I didn't get your entire question. Just chat up another question if you need some elaboration on that, but I do appreciate it. Okay, let's move on here. And so we're going to do a live setup and demonstration. And what we're going to do here, and this is the part you have to bear with us a little bit, is that I'm going to show you some Dranview data that was taken by one of our customers. We're not going to share their name because we did not get their permission to do so. And then we're going to pass it along to Ken, and Ken is going to show us how to set up the instrument properly for this application. And it's not a difficult setup, but it's the type of thing you need to know a couple tips to properly set up the recording depth for the instrument and a couple other things that are going to really benefit this setup. So just bear with me. I'm going to just share another screen here. Let me just share my Dranview software. So you guys should see that switch momentarily, and I think you did on our big screen over here. And this is actually a live test that was done by one of our customers. And just bear with me. I just want to minimize our chats here just for a second. So this is a traditional Dranview interface, and you can see the 3-pane browser. Let me just reproportion this a little bit. And on the left are the events that were recorded by the instrument in a chronological order. And you could choose any one of these events. I'm not going to do that right now because I have one selected. Then you have a timeline view, and you have an event detail view. So this is by 2-pane browser. We mean like window panes. And the left is the timeline. This is the historical measurements by the instrument. And on the right is any one event that I have selected either on the left or in my event view over here, all the way to the left, the far left view. All right. And we are using Dranview Enterprise here. And that's a good note that I probably should have put in the PowerPoint, that Dranview Pro, which is packaged with our visas, it can show this general information. your trends, but we use some advanced capabilities here, our timeline, our time plot calculator within DranView Enterprise to enhance the capabilities and compute frequency and some other information. So we do recommend that you use our DranView Enterprise software along with this test. If you purchase a Guide Explorer 400, packaged in with that is a copy of DranView Enterprise. If you purchase the Visa level products, you get DranView Pro. You can simply upgrade that. It's a separate paid for upgrade. It's not a lot of money, but you can upgrade to the Enterprise. And we really recommend that you do that. So what we're seeing here, and again, Ken will go through the details of what we're seeing, and I simplified this a little bit. This is the channel A voltage during the test. This is the channel A current during the test. And this is the frequency computed by DranView during this test. All right, and what we're really looking at, we're looking at transition, and the current tells the entire story here, as it does in many PQ things. So you can see here's the step transition that I was referring to before, where this particular user took it from 0 load to 25%, to 50%, to 75%, to 100%, held it, came down to 75, 50, 25, and back to 0%. Then he or she went from 0 to 25, 0 to 50, 0 to 75, and did 2 instances of 0 to 100% load. This is very typical what we see a lot of our customers do. We have some of the differences that we see are the hold times. We're not the ones to tell you how to properly test or commission the UPSs. I can just share what I've seen personally, and the other guys can chime in for other things. But the hold times vary, sometimes from seconds to minutes. We have a very large standby generator company that holds it for a minute and during the process. Others do it smaller. So it probably depends upon the size of the system. So as an example here, you can see that if you look at this point over here, I'm at 75% load, and you can see my vertical line here. That's my event marker. That's the event that I have highlighted here. So it's the event that's highlighted on the left. You can see these little tick marks here. That's the event that's right here. So I'm marking that event, and that event is the transition from 75 to 100% load. You could see that transition in current right over here. So if I just zoom in real quick, we'll just better show that. Oops, that's probably a little too far. So let's unzoom that. So we'll skip the zooming part because it's hard to get that sometimes, but you could see where it goes from 75 and that jump up to 100% load here. And you would see that. So this is used to make sure that it's properly working and commissioned, but also more importantly, if there is a problem, how to diagnose that. So that's one of the applications. So I'm going to pass it along to Ken here. I'm going to give him presentation rights and unmute him. And Ken's going to go through a live demonstration of setting up the HDPQ. You can see we have a thumbnail view of the HDPQ Plus here. It's in the back of the room. And so Ken's going to be controlling that particular instrument. You'll see a thumbnail view, but Ken will have it projected on the screen. So just bear with me and let me show it to him. We're going to give him control. Sorry.
Okay, thank you, Ross. Welcome, everyone. This is a little setup. We're going to do a setup for generator load tests. It's basically our power quality test, but we just got to make a couple modifications. What you do start a power quality test, you just start the setup. You go over to Wizard. Okay, go over to Wizard, and from Wizard, you start the thing. You know, we do a step-by-step monitoring setup. The first thing we have to do is hit next and enter your CTs. For our example right here, what we're going to do is assume 1,000 amps full load current. So what we have to do is set our CTs up for 3,000 amps. We want to be, right in the middle of that. And we're going to be monitoring our current on phases A, B, and C. Then you hit next. And the instrument will make a determination of what circuit you're on. If you notice right now, we're only simulating a three-phase Y. You can set this thing up with the instrument with a non-energized circuit or energized. You just got to know what you want to set up and how you want to set it up. So we want to do is three-phase Y, and you set it up. If you notice over here in the lower right-hand corner, we show you typical what you would expect, and the actual we show you what you're monitoring. So if you have a CT reverse or anything, it would show it to you right then and there. And it gives you a little warning saying mismatch, but you can override that because you know you want to do a three-phase Y or a three-phase delta as the data that Ross was showing you. So the main changes that we're going to do here is you want to put in your full load current. And as I said, we were going to do 1,000 amps. Everything else on this page is going to be pretty much the same. You can just leave it set up, then you hit next. And you just want to do standard power quality. In the US, it's IEEE, the rest of the world, 50 hertz, you would do IEC, but the rest of the page would stay pretty much same. You wouldn't make any other changes there. Then over here, you have a couple changes to make, not too many. One you'd have to do is you want to determine how long you want to record, your recording depth, and that's underneath the RMS events thresholds. What you have to do is go to pre-post, and the defaults for the instrument are 6 and 60. What you end up doing, what you want to do is set your pre-triggers to 30. That's half a second before. Now, your recording depth, you want to determine your settling or stabilization time of your generator or UPS. Remember that there's 60 cycles per second. So if your stabilization or settling time is 5 seconds, what I recommend is to double it to 10 seconds. So you would set up a recording depth of 600. And you'd have to do all three of them, the in, out, out, in, and post trigger to 600. And then get both pre-triggers to 30. So this way you'll be able to record the full settling of the generator or UPS that you're monitoring. Make sure you hit finish. You hit exit, you're going to jump all the way to the end. The other change that you have to make is under RMS difference. So you just click on here. And what we recommend here is 20% of your full load current. So since we did 1,000 amps, 20% is easy math of 200 amps. And then you just hit the set A, B, and C the same. Then you hit finish over here, and you have your basic 2 changes that you need to set up. Then you hit next. And you come to the final stage right here. I always recommend that you put a unique name on here. Too often I get calls from people that they left the default name and they overwrote a file because they didn't make any changes. So always pick a default name for any monitoring job that you do. And then save it. Just hit save. Okay. And then you just hit next. Now to start the monitoring, all you have to do is hit accept. And you have your instrument set up. And now you can start monitoring. So you see, it's simple, it's straightforward. There's only really two main changes. If you have any questions about this, you can ask the chat afterwards, or you can send an email to techsupport@dranetz.com, and either Thurman and I will answer that. You know, it's there for you. It's there at all times. So I'm going to turn it back to Ross now and go from here.
All right, thank you, Ken. I'm going to actually share another screen here, and I'm going to just grab this. One of the most important capabilities is the wave shape triggers that we spoke about. It is something very, very unique to the Dranetz instruments, but it is key to be able to detect these step loads. And there's an app note on our website. If you go to our technical documents, you will see the HDPQ wave shape triggers explained. So I just have that up there. I think we may have posted that on social media last week as just a link to this. And this is a key thing. And what this trigger basically does, it looks at your current voltage or current wave shape on each AC cycle, 50 or 60 hertz, and compares it to the previous wave shape, so the prior 50 or 60 hertz cycle. And it divides it into these little windows, and that's what Ken was describing. And as an example, if I divide this into 10%, it means I have 10 windows evenly distributed, as you can see here, throughout this cycle. So the algorithm looks at this window over here in time to that same window in time on the previous one, and goes for 10 more times on this. And it's looking for that change. And that's the important thing when we speak about this step load testing and things like that, where you can see the change and the instrument triggers on that change in current, either increasing or decreasing, and that's the trigger for the instrument. That's what makes it extremely unique for this particular application. So it's extremely powerful for that. And we greatly suggest that this capability be used for these applications. So please go check out our website, and you can see this directly, or even follow us on Facebook or LinkedIn, and you'll see a direct link to this particular application note. So just to go back to the software real quick, we'll go back to DranView, and we will just show you that. Again, these are the step load changes that we were referring to. Just to review what Ken said, there's just a couple things that you really need to change for this from the standard PQ mode monitoring that's in the instrument. One is the recording depth. Make sure you have the recording depth. We usually suggest 30 pre and X post. And the post that's for your application. So if you need it to be a minute, you might want to set it a little bit beyond that. So you guarantee you're going to get the pre and the post triggers from that. So the other thing to do is to set the wave shape triggers correctly. And, Ken described it very well, but you're looking at a percent change from one change, or a change in RMS voltage or current, in this case current, from one waveform to the previous waveform, 150 hertz or 60 hertz cycle to the previous one. That's the magic that makes this work, and why Dranetz succeeds and excels in this particular application.